The problem statement from GATE Physics 2016 reads as follows. A particle of rest mass m is moving along the positive x direction. This is the positive x direction. It decays into two photons, gamma 1 and gamma 2, as shown in the figure. The energy of gamma 1 is 1 giga electron volts and the energy of gamma 2 is 0.82 giga electron volts. The value of m in units of GeV per c square, where c is the speed of light, is this is a numerical answer type question, and we need to find our answer and round it off to two places and fill in the blank over here. Before we try to solve the problems involving relativistic kinematics, it's a good practice to have a few pre-checks, which are, we'll try to see whether the frames in the question mentioned are inertial or not. So everything which is being observed here, the mass m and the two photons, we'll assume that it's being observed from a rest frame. So that frame will naturally be an inertial frame. Second, we can see that there are no moving frames in the problem because everything is happening in the rest frame. So the question of moving frame speed and direction does not arise. So this is not applicable. And the number of dimensions here, the question, it says this is the positive x direction. However, you can see that these photons have a momentum also in this vertical direction, which I'll take as the y direction. So there are two dimensions over here, x and y respectively. Right, so this is the picture. Before decay we have a rest mass m and we don't know its velocity also. After decay, this is the two photons at the angle shown in the figure, and we'll try to apply the conservation of momentum, and we know the relativistic momentum for a mass is given by gamma mu, while photon is p equal to E by c. So first what I'll try to do is I'll try to balance in the y direction, so which I'll try to do over here. So for y direction, so y direction, the momentum for this mass is 0 because on the momentum is in the x direction, while in the y direction over here I can say that, so these are the momentums we can see, E by c. So this is 1 GeV over c. So I'll drop the GeV because everything is in GeV. So I can say that, so 1 over c, and then this vertical component will be sine 45. So 1 over c sine 45 minus, note that this component will be in the negative direction, so this will be 0.82 over c times sine 60. So let's try to evaluate this. So this will be this means 0 should be equal to, so sine 45 is 1 over root 2. We can drop the c term, it's common, minus 0.82 sine 60 is root 3 by 2. And if you try to evaluate, so I'll just get my calculator. So 1 by root 2 is 0.717, sorry, 0.707 minus root 3 by 2 would be, that would be 0.866 times 0.82, so that's coming out to be 0.710. So you can see that this is just for the second or third decimal place, so these are equal. So we can see that 0 equal to 0. So these values of essentially the value of energy that is given, it's correct. So but we don't get any useful information out of it. However, if I apply in z direction, note that there are two variables, u and m, so we need at least two equations. This equation was not of any use, so when we apply in next direction, so I can write gamma m u should be equal to the momentum of p1, the component of p1 in x direction, so that would be 1 over c cos 45 plus the second component for this the second photon would be 0.82 over c, that would be cos 60, right? So I can write gamma mu equal to 1 over c, cos 45 is 1 over root 2, that's 0.707, and that will come out to be 0.8, so I'll write this over here, 0.707 plus 0.82, cos 60 is half, so this is coming out to be, the total sum is coming out to be plus 0.41, so this is 0.707 plus 0.41 is coming out to be 1.117. So 1.117 by c. So I can say that yeah, so gamma mu is coming out to be 1.117 by c. This is my first expression. So so we already know that gamma would be equal to 1 over 1 minus u square over c square. So if you know u, you know gamma. So there are two variables, m and u over here. Now Now what we'll do for second expression, we'll apply conservation of energy. So how do we do that? These are the expressions. So note that this is a mass which is moving with some velocity u. So we'll use that gamma mc square equal to E1 plus E2. What are the energies? These are the corresponding energies. So 1 plus 0.82. So this will give me gamma mc square equal to 1.82. And if you recall, we already evaluated that gamma mu was 1.117 by c. So gamma mu was 1.117 by c. So what I'll try to do is I'll try to evaluate the value of gamma m and put it gamma m and put it over here. So this will be 1.117 by uc into c square equal to 1.82. So one c gets cancelled and I'll get c gets cancelled, u remains. So I'll get u equal to 1.117 over 1.82 times c. So what I'll get over here is 1 second. So this would be 1.117 divided by 1.82. This is coming out to be 0.614 c. So we have obtained the value of u. Now but we were needed the value of capital M. So in order to do that, we need to evaluate gamma also. So let's do that first. So gamma, was 1 minus u square over c square. So you put the value of u over here, that is 1614 c whole squared by c square. So that will come out to be, so we'll square that, and then we reduce it from 1 and we take a 1 over square root of that. So that comes out to be 1.267. So gamma is 1.267, and if you put it over here, so gamma is 1.267. I'm putting the value of gamma here and writing it here. So m c square equal to 1.82. So m will come out to be 1.82. Note there is a GeV being written over here, which I write right now, over c square over 1.267, right? So 1.82 over 1.267 is coming out to be 1.437 GeV over c square. So if I move forward, so the value of m was 1.437 GeV over c square. So units math, GeV over c square, and only 2 decimal places, so I'll round it off to 1.44 and I'll put this value over here. So that will be my answer. Thank you for listening.